I'm Eric, and I'm a software engineer on a team building an open source restaurant reservation service. I'm responsible for building the backend reservations API, and recently, while designing my system, I was faced with a decision to choose between a NoSQL database, MongoDB, and a SQL database, Postgres. I researched both databases and tested both of them, and ended up choosing Postgres. Here's why. I benchmarked each database by loading production-grade datasets, around 20 million rows each, into an instance of both databases. I performed read, write, update, and delete transactions on each instance, but I focused primarily on the read and write cache transactions. This is because for my reservations API, I believed and I expected that I would receive more read and write transactions than updates and deletes, and cache transactions would be more representative of production traffic. From a purely performance viewpoint, I actually determined that both databases achieved equally performant reads and writes, around 0 to 1 milliseconds on average. However, I did find that Postgres read speeds on secondary index columns were slightly faster, around half a millisecond or so faster, than Mongo read speeds on a similar query. So because both databases performed relatively equally, I determined that performance would not be a deciding factor in my decision, and so I turned to my use case. The biggest factor contributing to my selection between Postgres and Mongo was because my reservations API calls for transactional integrity and data availability of reservations data for a given restaurant. This means that I don't want two users to be able to simultaneously reserve a time slot if only one is available. And so this required my system to support both data durability and atomicity. After performing some research, I determined that both Mongo and Postgres support ACID compliance, at least on a per table or collection basis. Asynchronous replication methods were similar between Postgres and Mongo. However, I did find that Postgres supports two additional methods, which are synchronous replication that allow for stronger assurance of data consistency and lower data loss. Further, I, in the future, want to support multi-shard transactions in my database so that I can provide faster query speeds in both reads and writes. Normally with replication, there's a trade-off that needs to be made between data durability and then performance. And I believe that sharding will actually help me mitigate this trade-off between the two. This is because each shard allows for faster reads and writes, and the replication, which provides durability, will become more complex as there's going to be an increase in hot standby servers and elections that would need to be made if a primary shard goes down for some reason. I believe that the benefits of increased durability and performance by introducing sharding to my replication would outweigh the cost of the complexity. I looked into the MongoDB documentation, and as of the time of this video, the documentation explicitly states that Mongo does not support ACID compliance over multi-shard transactions. And so this put the nail in the coffin that Postgres would be my database of choice. Thanks for listening, and have a great rest of your night.